Lesson 2 of probability, and this is probability using counting methods. So remember, the probability of event A is the number of occurrences of event A over the number of occurrences in the sample space. And I always like to say probability is favorable over total, which is the number of favorable outcomes, and favorable isn't good or bad. There's no value judgments here. Favorable is the thing that we want to happen. So favorable is the thing that we want to happen, and the total is the total number of outcomes. So we're going to use our knowledge of calculating permutations and combinations to help us answer these probability questions. The word counted has been spelled out using Scrabble tiles. 2 tiles are randomly chosen. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so 7 letters. 2 tiles are randomly chosen one at a time and placed in the order in which they were chosen. Determine the probability the tiles are C and then O. Okay, so it's got to be a C, then it's got to be an O. So using a permutation, you could say it's 1P1 for the C, and remember, 1P1 for the O. So remember, and is times, and the total number of outcomes is 7P2. And we are using permutations because the order matters. Okay, so I could not say 2P1. Okay, I could say, or not 2P1, 2P2. But I could say 2C2, right? We could go 2C2. No, order doesn't matter. Yeah, 2C2 would be just change that. Forget it. Just stick with this, right? Fundamental counting principle. There's a C, there's 1, there's an O, there's 1, and then 7 times 6. Okay, and either way, this is going to work out to 1 out of, right? Let's give it a try. Well, 7P6 is 42, so 1 out of 42, and that will be what we find we get for 7P2, 7 math. Over to probability, permutation 2, 7P2 is 42. So 1 out of 42. Both vowels. Okay, so we got 1, 2, 3 vowels. So both vowels, we want all of the orders, right? So there are 3 values. There are 3 vowels. We want 2 of them. Order matters in this case, right? Because OU is different from UO. Right, we can tell that apart. 7P2 is all possibilities. So 3P2 divided by 7P2, so 3 math. Over to probability, P2. 3P2 is 6, so we get 6 out of 42, which is 1 out of 7. Okay, so the probability there of both vowels is 1 out of 7. Right? And this is the total number of arrangements of 2 tiles from a group of 7. Right? That's why we're using permutation and order matters. An athletic council decides to form a subcommittee of 7 council members. There are 9 males and 6 females on the council. Determine the probability the subcommittee will consist of. So a subcommittee implies that there is no particular order. Okay? So order does not matter. It's not the first person chosen will be the president, the second person, the vice president, etc., right? When you're forming a subcommittee, order does not matter. That makes this combinations. So exactly 3 females. So probability of exactly 3 females is probability of getting 3 females. So that's 6 choose 3. And the total number of subcommittees is 15. Oops. Don't write it as a fraction. 15 choose 7. And if you like, you say 6. Well, not if you like. We need 7 people, right? So there are 6 females, I want 3 of them. There are 9 males, I need a subcommittee of 7. So it's 6 choose 3 times 9 choose 4 over 15 choose 7. All right, let's work each of these out individually. So 6, math, over probability, choose 3. Okay, order doesn't matter. So 20 times 9, there are 9 males. And we need 4 of them. Oops, do not do P. So clear that. 9, math, over to probability, choose. 9 choose 4. Okay, again, order doesn't matter. 126. And the total number of 7. So in probability, the top part we've done up until now, we would have said, how many ways are there of choosing, right? Which would have been 20 times 126. This is the probability, so it's how many ways, the favorable, but the total number of outcomes. And a lot of times we'll work that out as well. The total number of 7-person subcommittees from a group of 15 is 6,435. Okay, so we have bracket, so I'm going to do 20 times 126 divided by, now you need to bracket that, right? You need to work that out first. I'm waving my hands about as I say this, as if that makes a difference. So 0.39, now does it say what? So let's multiply that by 100. 39.16%. So one reason that I like to do 4 decimal places as a decimal is that becomes 2 decimal places as a percent. Okay, and it should say something like rounded to the nearest whole percent or rounded to the nearest tenth or whatever. We'll just give it as 2 decimals. That'll keep things cool that way. At least 6 males. So that is 6 males or 7 males. So 6 males. 6, there are 9 males. 9 choose 6. There's 6 females and we need 7 people. Okay, no. 9 choose 6. 6 females, we need 7, 1. Or plus 9 choose 7. You can put this in or not, right? 6 choose 0. And our denominator is always going to be the total number of committees. So 15 choose 7. And that is equal to, okay, so you can watch as I do this. So we want, let's do this. We'll put a bracket down. We'll go 9 choose 6. Okay, up arrow to move up, times 6 choose 1, which is really just 1. I mean, sorry, it's really just 6. Okay, but we'll do that. Or, so plus, oops, don't do that down there. Okay, so kick over, plus 9 choose 7, 9 math, choose 7. Don't put the bracket there. Kick over. Now, 6 choose 0 or anything choose 0 is just 1. So that's our total. Let's work it out. So 540. So 540 out of 6,435. Okay, we already worked that out there. So divided by 6,435 is 0.0839. Let's just multiply by 100 and we'll go as a percent, 2 decimals, 8.39%. 8.39%. And really the other thing we can do is, let's take this number, and let's convert it to a fraction. So math to fraction, because the other way that this could be shown, all right, that's not going to convert. That should. Hang on. So 540 divided by 6,435. Math. Enter. 12 out of 143. Okay. So it is possible that it is a reduced fraction, right? In which case we should know how to do that. 540 divided by 6,435. to frac, right? Math, enter, enter. So you may see your answer as reduced fraction. You may see it as a decimal, 0.084 perhaps, 0.08 perhaps. You might see it as a percent. So just get used to different ways of seeing it. Ms. Cheney, who is on the council, one of the council members, is on the subcommittee. Okay, so let's do this. One, choose one. There is one Ms. Cheney, and we will choose her. There are 14 remaining people, and we will choose 6. So our top numbers add to 15. 15 here, right? In this case, the females and the males. 15 here. 15 here. 7. These add to 7. These add to 7. These add to 7. Over 15, choose 7. So really, it's just 14, choose 6. So 14, math, over to probability, choose 6. The one, choose 1 is just 1. Okay, let's get that actual. So 3003 divided by 6435. So if I go divided by 6435, math, enter, enter. Reduced fractions, 7 out of 15. Okay, I can go math, change that to a decimal. 0.47, 0.4667, multiply by 100 to get a percent, 46.67%. So consider this sort of the raw fraction. In other words, it's the actual number, and on the bottom, the actual number. Then the reduced fraction, 7 out of 15, and then the decimal and the percent. Ms. Cheney and exactly 3 males. So 1, choose 1. There's 1 Ms. Cheney. From the 9 males, we want 3 of them. From the 6 females, but we already have 1 of those females. So again, remember, these have to add to 15. So if you put 6 there for the 6 females, what you've done is you discounted the fact Ms. Cheney is 1 of the females. So 1 plus 9 is 10, plus 5 is 15. 1 plus 3 is 4, and we need 3. So there'll be Ms. Cheney, 3 males, and 3 other females. 1, choose 1 is just 1, right? So we need 9, math, choose 3, okay, and remember to kick up there, times 5, math, choose 3, oops, I wiped out the whole thing. 9, math, choose 3, times 5, math, let's see if we can get this right, choose 3, okay, will be 840 out of, and our total is still always going to be the same, right? So divided by 6435, so oops, we can get that. Then math, enter, enter. Let's see if this converts to a fraction. Yeah, 56 out of 429. 0.1305, 0.1305, or 13.05%, or 13% to the nearest percent. So again, our answer could be expressed in many different ways. The raw fraction, the reduced fraction, a decimal, and a percent. Oh, this was a bad split. That's supposed to be on its own page. But in a card game, you are dealt 5 cards from a standard deck of 52. People are always asking about the jokers, but in card games, generally we are not including jokers when we're working on probabilities. So in a card game, you are dealt 5 cards from a standard deck of 52 cards. Determine each probability expressed in combination notation. Okay, so in other words, we are not going to do this as a decimal or as a fraction or as a reduced decimal. or anything like that. We're just going to do it in combination notation. Okay, 4 aces. So we're going to get 5 cards. There are 4 aces. I need all 4 of them. So 4 choose 4. There are 48 cards which are not aces. I need 1 of them. And our denominator is always going to be 52 choose 5. And just to put in perspective, right? We're not using this here, but just to put in perspective, 4 card game, so 52 choose 5. If we are talking about that, that is 2,598,960. Okay, 52 choose 5. So any 5 card game you're playing, there are 2,598,960 possible combinations. Right? Remember, combinations are where order does not matter. 4 tens. Your French teacher, 4 tens. And 1 ace. So there are 4 tens. We want all 4 of them. There's actually only 1 combination, right? Because we don't care about order, so order doesn't matter. Just you've got all 4 tens. You've got 1 ace. There are 44 cards left, of which you want 0. Generally speaking, we're probably not going to put that in. And 52 choose not 0. 52 choose 5 for the total number. Okay. Again, we're not working any of these out, just leaving answers in combination. No more than 2 5s. So no 5s, or 1 5, or 2 5s. Let's put words down. No 5s, or 1 5, or 2 5s. So no more than 2. None, or 1, or 2, right? And be very explicit using the language, or, right? Because remember, or, no 5s. There are 4 5s. I want none of them. There are 48 other cards. I want 5 of them. Or, there are 4 5s. I want 1 of them. There are 48 other cards. I need 4 of them. Or, there are 2 5s. Sorry, there are 4 5s. I want 2 of them. There are 48 other cards. I want 3 of them. Over 52 choose 5. Okay, so no 5s, or 1 5, or 2 5s. Now, another way that this could be done, so if you don't see this as an answer in combination notation, then potentially it gets written like this. So what are the other possibilities, right? You can have no 5s, or 1 5, or 2 5s, or 3 or 4. So you could say, if we take the total number of possibilities, and from that we subtract you getting 3 5s, which is 48 choose 3, 48 choose 2, or 4 5s, so 4 choose 4, 48 choose 1, divided by, I'm going to mess that up, so the whole thing divided by 52 choose 5 for probability. But basically what we're saying is the numerator could be this, but it could also equivalently be that. So all possible combinations minus the ones that have 3 5s or 4 5s. Okay, so from all you take away 3 or 4, what you're left with is no 5 or 1 5 or 2 5s. And that idea here is what we're going to use for at least 1 jack. So we have no jacks, or 1 jack, or 2 jacks, or 3 jacks, or 4 jacks. So if we have at least 1 jack, the way to think about this is we don't have no jacks. So 52 choose 5. That's all possibilities. From that we subtract no jacks. There are 4 jacks, we want none of them. There are 48 other cards, we want 5 of them. And 52 choose 5 for the denominator because it's a probability. So any of these questions we're asking here could also be asked in the last unit on combinatorics, right? Because there, what we have been doing is simply the numerator, right? Just how many ways can this happen? And this time, how many ways, that's favorable. But in a probability, we need the total number of outcomes. So here are the total number of outcomes. We always have this denominator of 52 choose 5. Okay, let's get rid of those little circles. Or not. Guess not. And then the other way this could be done is you could go 4 choose 1, 48 choose 4, plus 4 choose 2, 48 choose 3, plus 4 choose 3, 48 choose 2, plus 4 choose 4, 48 choose 1, over 52 choose 5. A password is required for your FaceSpace account. If a password has to consist of 3 uppercase letters followed by 3 non-zero digits, determine the probability that the password could contain the letters A, B, C in any order if both letters and digits can be repeated, and in part B, cannot be repeated. Okay, so if we can repeat, determine the probability that contains the letters A, B, C in any order. I'm going to do this using the fundamental counting principle. So 3 uppercase letters. So it's got to contain the letter A, 1, B, 1, C, 1, and any 3 non-zero digits. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if we can repeat, it's going to be 9, 9, 9. And the total, 26, 26, 26, 9, 9, 9. Okay, so we can repeat any of the 26 letters, any of the 26 letters, any of the 26 letters, any of the digits, any of the digits, any of the digits, as long as they are non-zero. And this is going to work out to 1 over, so the 9s will cancel. It'd be 1 over 26 cubed. So what's 26 cubed is 17576. So 1 over 17576. 1 divided by that number. Just we're going to get small now, right? So 5.69 times 10 to the negative 5. Cannot be repeated. We cannot repeat. So still, we need ABC in any order. You messed that up. Okay, so you got 3 choices, then 2, then 1. That's a 6. That's a 6. Clean that up. So in any order could be the A, then the B, then the C. Let's clean this up. So first letter, 3 choices. Second letter, 2 choices. Third letter, 1 choice. All right, let's get this. It's 6. So 6 divided by 17576. Math. Enter. Enter. So 3 out of 8, 7, 8, 8. 8, 7, 8, 8. Convert that to a decimal. Number 2 to decimal. Equals 3.41 times 10 to the negative 4. Okay, helps to read the question. So ABC, no, not going to do that. It's first letter, second, third. So 3 choices, 2 choice, 1 choice. 9 choices for the first, we cannot repeat. Then 8, then 7, so it can't be 0. Down here. So this is favorable. You've got your ABC, and then you've got your 3 digits, no repetition. Here, 26, 25, 24, 9, 8, 7. Okay, so it's going to be 6 over 26 times 25 times 24. So 26 times 25 times 24 is 15,600. 6 out of 15,600. Okay, let's see if we can reduce that. Divided by that. Okay, math, and then enter. So we got the decimal. So 1 out of 2,600, probability is 1 out of 2,600, or 3.85. 85 times 10 to the negative 4. Okay, so those are the probabilities, right? Last unit, we would have just asked for this, or maybe this, right? What's the total number? What's the total number of these with this condition, and what's the total number without regards to any conditions? There are 10 runners, not a new problem. There are 10 runners on the cross-country team, all with roughly the same ability. The coach has decided to randomly choose 4 runners to run in the first race. Annie and Bobby are on the team. Determine the probability of Annie and Bobby both being chosen to run in the first race. Okay, so we don't care about their order, right? We're not doing finishing orders or anything here. We're just wondering of the 4 runners that are chosen. So there is one Annie, and I want her. There's one Bobby, and I want her. There are 10 runners in total, so these numbers add up to 10. 4 runners being chosen, so those numbers add up to 4. So there are 8 runners remaining, of whom we need 2. And there are 10 choose 4 ways of getting them. So 8 choose 2. 8 math over probability, choose 2, 28, 10 choose 4, 10 math probability, choose 4, 2 10. So I like to call that the raw probability, right? Because it's the actual count. As a decimal, so let's do this first, math, enter, enter. So as a reduced fraction, that's 2 out of 15. Could be presented this way, could be presented this way. As a decimal, so could be presented 0.133 or 13.33%. So there's a 13%, a little over 13% chance of both being chosen. Determine the odds in favor of Annie and Bobby both being chosen. Odds in favor is favorable. So we could go 28 to 210, which if we did, that would be wrong. Okay, it's 28 to 210 minus 28. Okay, so 28 to 210 minus 28. All right. 210 minus 28 is 182. So 28 to 182. Now to reduce that, well, actually just look here. So it would be 2 to 13. So remember, this is the total. That's 15 is the total. So odds in favor are favorable. So odds in favor will always be the numerator of any probability. Okay, and then the unfavorable will always be the denominator minus the numerator, so 2 to 13. And if I go 28 divided by 182, 28 divided by 182, math, enter. And when I hit enter, it's going to say 2 over 13. Okay, now remember, don't write it as a fraction, write it as a ratio, 2 to 13. So favorable, odds in favor, total. And I think that's it. We're done. 2 down.